वॉइस ऑन करना. Pradeep, I have sent it to you on your official wala mail. Can you hear me? हाँ. Come on, we have to go live also. I think we'll manage.
Yes.
Yeah.
You have a nice big auditorium.
Oh. Yeah, Pradeep, are you ready? Your mic is off. अच्छा, उसमें जा रहा है. वो दे मुझे. बात करनी है ना. Okay, that's good.
He can bring it in the presentation mode, full screen, you know.
Yeah, they'll just do it.
Yeah.
So now, we are just starting.
Okay, we can start, I think, now.
Yes.
Okay.
Oh, yeah, now. I request all the participants to mute or silent their phone. Words may inspire, but action. Good morning to all the dignitaries present, all the faculty members, all the participants. So let's start today's webinar on managing and leading in a digital world powered by artificial intelligence, data, and cloud. In today's era of volatility, there is no other way but to reinvent. The only sustainable advantage you can have over others is agility, because nothing else is sustainable. Everything else you create, somebody else will replicate. ऐसी शख्सियत का परिचय देने का जो कि आईटी इंडस्ट्री की आन बान शान है और इस भारतवर्ष का गौरव है, चूंकि इन्होंने काफी वर्षों तक सेना में अपना पराक्रम साबित किया है. इस महान शख्सियत का नाम है लेफ्टिनेंट कर्नल राजीव शर्मा. वर्तमान में राजीव जी ग्रिड डायनामिक्स के जो कि एक नास्डॉक लिस्टेड कंपनी है जिसका हेडक्वार्टर है. इनको 25 वर्षों से ज्यादा का लीडरशिप और मैनेजमेंट का अनुभव है. साथ ही इनका इंजीनियरिंग में आर्टिफिशियल इंटेलिजेंस के एंटरप्राइजेस आर्किटेक्चर के अंदर प्रोडक्ट डिजाइन एंड डेवलपमेंट, सॉल्यूशन क्वांटिटेटिव एनालिसिस, एल्गोरिथम और मैथमेटिकल मॉडलिंग के अंदर अपने आप को ग्रिड डायनामिक्स में कार्य करने से पूर्व प्रमाणित कर रखा है. लेफ्टिनेंट कर्नल राजीव शर्मा ने सीनियर वाइस प्रेसिडेंट के पद पर कॉग्निटिव डिजिटल इंजीनियरिंग अंदर अपनी सेवाएं दी. भारतीय मूल के यह इन्होंने स्पेशलाइज्ड डीप लर्निंग में नोवा आईक्यू नामक. So moving further, it gives me immense pleasure to invite the Vice Chancellor Sir, Mandsauri University, Dr. Brigadier Bharat Singh Rawat. Welcome address.
Yeah. Okay, students, faculty members, good morning to all of you. Our Chairman Sri Narendra Nahata and all of you at Mandsauri University, I extend a hearty welcome to Colonel Rajiv Sharma. I've known him for past 30 years. We've been colleagues. We've been together He's an excellent engineer, a scientist, a keen innovator, a motivated, a wonderful human being. He is alumni of one of the best institutions in the country and the world. He graduated from BITS, Messer Ranchi, went on to MIT, then to Harvard. I may have mixed up the sequence. Rajiv, you will have to forgive me for that.
All good, sir.
And an
All good.
expert, and an expert in giving AI solutions to clients and solving complex has been doing for last 25 years. Well, you all have been introduced to the impact of artificial intelligence on industry, society, and economics. He'll tell you how you have to role in this transformational era of AI, IoT, big, and all these technologies in the digital world. So the popularity of AI are increasing every day, and it has evolved itself in the last few years and has found application in almost every field. Expected to grow at the rate of 54% every year. With the digital environment had changed the complete dynamics of marketing and decision making. So you as engineers tomorrow have to familiarize yourself with a large number of the tools and technology floating around you in the environment. So this is where Colonel Rajiv Sharma will help you in managing and leading. So put your hands together to welcome him and give him a big.
Okay. Thank you, sir. Thank you very much. I hope I am audible. If anybody can give me a thumbs up if I'm audible.
Yes.
Okay. Thank you. So today's talk is for you, and I have tried to put this material together specifically for the students and the faculty members at the university. And this is based on my personal experience building artificial intelligence platform on the cloud for large complex enterprises powered by very complex sources of data. I will try to lay this material in a simple manner. And the goal of this material is to make sure that you get comfortable with the idea of a digital world and a digital transformation and are able to find your place in this value chain. There are many myths around AI, cloud, and data, and I want to remove some of them. We can go to the next slide. The digital economy, this word was coined by Donald Tapscott. There was a book on this topic, if you can Google that. And this was written in late 90s. And as late as 2015, digital economy was a topic in the World Economic Forum at Davos. And at that conference, it was, many of the leading eminent people mentioned that it is still 10, 15 years away, the full benefits of a digital economy. And we are already in 2021. Today we are sitting on the cusp of a huge transformation and the way we live our lives. Next slide, please. So what is the central idea? And let me build this for AI and cloud and data. But what is the central idea? The central idea is it's all about the economy. It's all about the integration of enterprises with the socio-economic fabric of any country. And this is based basically on the principles of how you can digitize the business steps that you have so that it can be communicated and you can exchange value digitally, right? The whole idea is you're taking advantage of the internet, right? And one of my professors at MIT, Professor Eric Brynjolfsson, very early he mentioned that advantage of digitizing thing is it has a near zero marginal cost. Once you digitize something, you can make as many copies of it as much as you want, and you can send it to any part of the world anytime, as long as you are on the internet. So basically, the internet and the digital assets become a part of the economic activity, which is the digital economy, where there are people who are buying, selling, and people are benefiting from that. And in this digital economy, it's all about networked systems, networked societies, networked communities, and networked businesses. Right? And this also allows you for collaboration transparently and using the power of cloud. And some of you are studying cloud, some of you are teaching cloud, some of you are studying AI and data and machine learning, and some of you are studying software engineering, and some of you are in the business environment, business school environments. Now, so you understand that, and every day you buy something on the internet, you are taking part in the digital economy. Now, next slide, please. The digital platform, the world of digital platform itself has changed. Now, if you look at the MIT Center of Information and Software Research, incidentally, many years ago, when I had come here to study, I had taken a course called Generating Business Value from IT. And in that center, they were actually trying to define what is a digital platform, what is a digitized platform. And they were saying it is a set of some standard business processes like logging in, authenticating yourself, clicking on something and saying, okay, make the payment or select some items, all these business processes. And these are supported because they're sitting on some infrastructure, some virtual machines, where on some servers where these applications are running. And there is a database to support the application. And all of them are running in a very stable, predictable manner. This is a very simple definition put forth at MIT. Fast forward so many years now, we are in 2021. The essence is the same, but the way platforms are built today has changed, a lot. Today, everything, and as I said, I have tried to bring my personal experience so that I don't share something with you that you can Google. Right? I wanted to share something experiential with you as we built AI and ML platforms for the Wall Street, for the retail businesses, for the consumer product goods, for the manufacturing businesses, for the logistics businesses. The way the platforms are built have changed drastically. Today, the platforms are built in a very, Lego blocks kind of the way you see on the picture. Right? These are small, so logging could be a service, and it is sitting in imagine a container, and you can reach this. Anybody in your company can, if somebody is designing another application, it doesn't have to rewrite the login page code. It can take this login page, and it's a reusable component, and it can be sitting in a container and exposed as a service. It's like having the address for that, and anybody can use that by integrating it in your software. Now, in the older, just about 10, 15 years ago, and why 10, 15? Even now, a day before yesterday, I would say on Monday, the Monday that has just gone by, I was on a call with a large, shoe company. I don't want to name it, but they say just do it, right? So there is a huge initiative for replatforming, making old monolith platforms and replatforming them into a microservices based architecture. Imagine in a monolith, when you write some code, everything is integrated from front end to the middle layer to the back end. Everything is integrated. Imagine a big box where everything internally is wired and tightly coupled, and you can't put pieces aside. Now, when you make a change on the front end or any one piece of code, just imagine every time you have to test it, you have to run the whole code for the whole box. You can't just test one small piece. And common sense will tell you that this is not the best way to build any platform today. So this diagram that you see here was from one of my experiences for building something for a Canadian large retailer, and they had a monolith platform. I can't give the details of that, but it took more than 2 business days to change something, test something, and then redeploy. When you build a monolith platform coupled with automation, QA automation, and DevOps and other processes, this could be deployed in less than an hour, right? So the digital platform thinking has changed. Next slide, please. Now, as you know, the world, now we are all clear about the digital economy. It's all about running economics in the society, in a community, using the power of internet and applications, which are IT applications, and how you consume them. You consume Facebook, you consume WhatsApp, you consume Gmail. There are so many things. You go to Myntra.com to buy clothes. There are so much of consumption that is already happening, economic activity happening on the internet, and the entire philosophy is that there are some business models. For example, WhatsApp is a freemium model. It's free. You can just maybe pay $1.99 or something, and you can get a WhatsApp app. There are many apps that are free. Gmail, anybody can use Gmail for free. So there are, and then there are technologies. So there are different types of business models, like the freemium model, the subscription model, the one-time payment model. There are different business models on the internet, or pay for what you use, like the cloud platform. There are many business models, and there are many products and platforms. And all these are possible because of the technology stack. Now, all these 3 pieces form an organization, an enterprise. And such an enterprise is a digital enterprise. And many such enterprises will form a digital ecosystem. Now, we as engineers, as management students or management leaders and engineering leaders, we may decide to operate in a domain, or you may operate as technologists, as engineers. And some have the talent and the ability to be both. They have good engineering acumen, and they are very smart management leaders, the technocrats, as you may know them. Now, important thing to know is that all these organizations, they do 3 things. They engage in entrepreneurial activities. That means they create new products and services every time to remain relevant in the market. They do operations work so that they continue to build products and services at minimum cost and in the shortest possible time. And there is a whole machinery which makes sure that the company is running in a smooth manner. The finance, marketing, the infrastructure, HR. There are whole operational teams, functional teams, trying to make sure that the entrepreneurial work of doing what you do, whether you're a shoe company or a retail company or a manufacturing company, you should be able to do your entrepreneurial work. And then there is a marketing piece where you need to reach your customer. Your customers have to know about you so that they can buy your products and services. Every organization engages in these 3 activities. You can Google Igor Ansoff, one of his best strategic management books, which is a classic, mentions that any organization which is engaged in a for-profit activity or even non-profit activity has to do these 3 things. Now, you need to understand that doing these 3 things requires an interplay of business models, products and platform, and technology. And you need experts who are domain experts, and you need technologists, and a combination of 2 to make sure that this entire digital ecosystem flourishes. So this is a very complex, non-linear activity. Next slide, please. So the question is, why do you say that we have to be quick in understanding our customers? We have to be quick in making changes to our products. You can't just do that unless the technology fabric of the company allows you to do that. Even if you're a shop floor manager and there is some spare part, some problem in the part, or there is a leak in the gasket, and you want to inform someone, you may, and you're on the shop floor, there's a lot of noise, you can't just pick up a cell phone because you want to record the activity. So you may want to do it on the system. You need a system on the shop floor. It has to be digitally recorded with a timestamp. And then this will go to some other manager who will say, okay, please get another gasket from the inventory, from the stock, and I approve it. So there is a workflow. All these business processes have to be on the system so that there is an audit trail. And then all this data has to be used to train some statistical model to predict future failures. And all the prediction model that is learning from this data have to be trained regularly at regular intervals of time. And I'll come to that in a bit. I don't want to jump the gun. So organizations have to have agility so that they can go to the market fast. They can spread the word within the company quickly. There is a discipline on how you do things. And then everybody should find it easy to work. Imagine you come to work and your system is not working and you will lose your cool. Okay, nothing works here, right? So agile organizations can quickly respond to the market, can quickly change their strategy, can quickly introduce new products and do new value creating work for the company only if it is a digitally transformed organization with all the bits and pieces digital, working together and working intelligently. Next slide, please. Now, in all this digital conversation, many of us are aware of statistical modeling, and many of us are aware of, heard about cloud. You're studying databases, but the story is a little bit. There's a twist in the story because of the new fire because of the artificial intelligence. The 80s and the 60s, 70s and the 80s saw a lot of drop in the AI research and activities. It's called the AI winter. Because while people knew about neural networks and statistical modeling, they did not have the ability to run these models and train these models because it needed a lot of compute power and you needed large amount of data to train the machine, the storage power for the large data and accessibility. Now, the story with AI in all this digital world is slightly different. On the left, if you see the old world, we had some data, we applied some business rules, and we got some insights. We plotted them on Tableau or ClickView or Excel plots. There was always some data, and you always had some pivot tables, pivot points, some filters, some rules, and you got some good-looking dashboards. Now, when you're training a machine, right, on the right side, now you have the same data. Now you put that same data in a box, but this box is now a statistical model or a deep neural network, and I'll come to that in a bit. Now, along with this data, you also feed in some past data. For example, fire is hot, water is cold, and you can feed a lot of data about water and fire and label them. This is water, this is fire, this is water, this is fire, this is hot, this is cold. And you can keep these labels, or this is a cat and a dog. And now you train the machine on the labels, that when you see this data, it is this label. When you see this data, it is this label. And you train the machine again and again for that pattern. Now, that data becomes a vector. The cat and the dog becomes a number. And then every time you show a dog and a cat, the vectors are compared. And when the two vectors are very close to one another, it says it is a cat, or it is water, or it is fire. And that is your model, the trained model. So in the past, we had data and some rules, and you got some insights. Now you have some data and some labeled data for supervised, for training a machine. And what you get is a trained machine, a trained model. Just like if I would join Mansoor University, somebody will take me around and guide me, okay, you're the new professor here, this is your class, never go here, these are the do's and the don'ts, this is our culture. Somebody is going to train me as a human. And I need that data. Somebody is going to feed me with the ethical standards, the training standards, the teaching standards at Mansour University. And I will be trained slowly. I will make some mistakes, but somebody is there to guide me that, no, this is not done. This is not how we teach, or this is not what we do. And I will learn over a period of time the culture and the conduct methods at Mansour University. Similarly, so, you train a model. So with the AI piece, the story has got a little bit flipped. And there is no AI, no data, no cloud, no AI. So imagine, please understand that, and I say this with a lot of experience. Many organizations have called me and I've interacted with them. They want to do something in AI, and they don't know which business problem to pick up with AI. And that's a wrong place to start. You first have to understand, what is the business problem? Do I have enough data of past behavior for this business problem? Can I use that labeled data and the new data that comes in to train a machine? Is it a problem worth solving autonomously by a machine? And then you decide to do what you do. So you need a lot of data, historical data. You need the right business problem that is ripe, which is perfect to be solved by a machine. And then you need the compute and the storage power to store that large amount of data, and the machine that gives you the compute power to run the algorithm again and again and again, like iteratively, till the time the model accuracy improves. And it's simple. You feed a picture of a dog, you feed some data, labeled data, say this is dog. Slowly the machine will learn it is dog. Now, when you feed the actual picture, and the machine will say it's a cat. So there is a vector called dog, a mathematical number. There is a mathematical number for cat. You match the distance between the two vectors. It's not going to be the same. And you feed the error into the machine again till the time the machine becomes good and says a dog is a dog, a cat is a cat, up is an up, and down is a down. That is when you have a trained model. But for this, you need data and you need the compute and storage power. So no cloud, no data, forget about AI. And all these are part of a strong digital enterprise. And for you to become a part of such a digital, for you to manage and lead and find your place in such a digital organization that engages in a digital economy, you need to understand how this whole thing works as a whole. It is not about coding, and it is not about solving algorithms. It is the whole orchestra. And let me come to that. Next slide, please. Now, as I said, no cloud, no data, no AI. Right? Now, because of the cloud, you're able to use, you don't have to buy a server. I'm a school student, or maybe my parents give me, say, 1,000 rupees a month or 2,000 rupees a month. I'm from a modest family. Now, I can still go and buy a cloud server. I have a small computer. I can connect to the internet. I can go to a library and connect to the internet. There are places which give you free Wi-Fi. I can write an application and I can go to the cloud, train my model or do something, and I'm up. And I only pay for what I use. And that is called, and as I need more compute power, I'll add some more servers or select some higher computing power. I'll pay more, definitely, but I'm paying for what I'm using. So cloud is best for scaling, and you only pay for what you use. So it is an operational expense. It is not that no matter whether I use it or no, I have to pay 5,000 rupees. It's not going to be like that. So cloud gives you the flexibility. It allows you to scale slowly as the complexity increases. And then you can control your costs. You can monitor stuff on the cloud, and you can store large data in your cloud coming from different sources, from the sales, marketing, HR, many departments, from the machinery plant. All this data can come, and you can store it in the cloud at a much cheaper cost than buying a large server for a database. Right. Now, you're able to break all the silos. So earlier, salespeople saw sales data, marketing people saw marketing data, shop floor people saw shop floor data. But you are able to see all the data because you've taken the data, they call data pipelines. So you build the data pipelines and you put it in one place called the data lake on the cloud. So this is called data modernization, data engineering. Because of such possibilities on the cloud, building multiple pipelines and storing data on the cloud, using cloud assets to compute and store and train the statistical models, you're able to do data management, you're able to do AI enablement of your process, and you're able to store large amount of data, which is sitting in somebody different silos, and the left hand does not know what the right hand is doing. This is part of the legacy transformation, digital transformation. This is what a digital transformation many times is all about. In 8 out of 10 companies that I've worked in my last 16 years in the US, in 8 out of 9, 8 out of 10, this was the fundamental problem. They did not have data available easily from different departments. It was all fractional and siloed, and they were on their private data center. And now they wanted to migrate to the cloud. This itself is a huge multi-million-dollar engagement for many companies. A cloud migration program can take 3 to 7 months, 8 months, sometimes even 2 years, depending on the number of applications. And it can cost companies in multiple millions of dollars. Same goes with data modernization and data consolidation on the cloud. Because of this, you're able to gain insights like never before. You're able to go to market, get insights fastest because of the different types of data you can put together. You're able to build products and services because now you understand customers better. अरे जैसे आप बोलोगे अरे ये तो हमने कभी देखा ही नहीं, ये प्लॉट तो पहले ये XY प्लॉट तो कभी था ही नहीं, कभी दिखा ही नहीं हमें, बिकॉज ये डेटा कभी था ही नहीं हमारे पास. So these are important pieces, right? When you don't have certain data which is now available to you on the cloud because of the data pipelines, this is the time to insight which gets shortened. So now you can go to market with new products and services. आप अपने customers को अच्छी तरह समझ सकते हैं. आप समझ सकते हैं कि इस प्रोडक्ट में ये कमियां थी और ये कस्टमर का फीडबैक है. आप उसको एनालाइज कर सकते हो. You can analyze it quickly on the cloud using the tools available on the cloud. And you can reach your customers anytime, anywhere. Like you can go to Flipkart, you can go to eBay, you can go to Amazon. Doesn't matter where you are. And you can thrive and grow revenues and markets and customer segments like never before. But this is possible because of the digital integration of AI, data, and cloud, and people who manage this business vision, right? It's an orchestra. And I'm trying to help you to understand that wherever you are in your engineering journey, wherever you are in your management studies journey, this whole value chain has place for everybody. And I'm trying to help you from some real life cases here, that how you can manage your career, manage your skills and assets, personal assets, to find a way into this digital ecosystem and get a very good foothold in a global ecosystem of opportunities. Next slide. Now, the value proposition, I was saying that AI is a general purpose technology, like electricity, right? And again, all this you can Google. So I'm not going to give you information that you can Google. So what the problem is, even today, as early as late as last week, companies ask, what is the kind of business problem that I can solve with AI and cloud and data? And if you tell them that you can increase your revenue, you can improve productivity, you can improve customer experience, you can reduce your cost, and he'll say, "Arey, ye to main abhi bhi kar raha hu yaar." So again, why do I use AI and what am I not doing? The question is, somebody is doing the same thing you're doing cheaper. Somebody is doing the same thing you're doing faster. Amazon is eating everybody's lunch. Amazon is now getting into medical insurance. Amazon is getting into pharmacy drug deliveries. Why? Because they're integrated. Amazon transportation integrated with the road transportation, integrated with air transportation, integrated with ship transformation, integrated to the warehouse. They have one-stop real-time information which package is where. Compared to any other company that cannot do that. They have to send an email, make a request. कहाँ पहुंचा हमारा डब्बा? अभी कैसे जाएगा? अभी ट्रेन से, अभी शिप में जाना है, कैसे जाएगा? If they're not integrated. So the question is, it's not that oh, AI can do all this, I'm already doing it. The question is, if you don't do it, you will be out of the market very fast. If you look at the S&P 500 companies in the 60s, all these large companies were in the S&P Standard & Poor's portfolio rating for 30 years, 26 years. They used to be on the part of the S&P 500 bucket. Today, that timeline is 14 years. Bear Stearns, the financial company, is wiped out, bankrupt. Lehman is wiped out. There are so many companies. Yahoo was absorbed by Verizon. Now, of course, they have sold it back and they've come out. But the digital transformation is serious business. Integrating processes, applications, cloud, AI, and the user experience. When you use your phone, you see the right color, you see the right app, you don't see the screen getting cut. The user experience design is perfect. These are a very critical part of product management, product development. And then, so now when AI comes into the picture, it can impact all the dimensions of business. Revenue, productivity, customer experience, cost, different types of business problems. And the way you can do today is, you can do unsupervised learning where you don't know the label data, you don't know whether this is hot or cold. You actually kind of study the data, just like you're going into a new locality. You look at a bank, you look at a school, you say, acha, usne bola tha ke mera ghar school ke baju mein hai. So you'll try to look at the school. This is unsupervised learning. This is how they're training the auto-driving autonomous cars. A lot of unsupervised learning, and then some supervised learning, and a combination of in a computer vision and mechatronics and so many other things. So you will have different types of methods of unsupervised, supervised, and reinforcement learning, but all these are useless if it is minus the cloud and the data. So remember always, 5 models cannot transform the company. 400 models cannot transform the company. If there is no way to consume these models through API integrations available always on the 24/7 high available architecture, reusable high available architecture. आप रात को भी उठ के अपना WhatsApp देखते हो, आपको दिखाई देता है. आपको अपना emails, Gmails दिखाई देते हैं. So these are always highly available systems. And to stitch this together, you need certain skills of engineering, of product management, and business envisioning. There is a place for a whole lot of skill sets in such a digital organization. But remember, it's just not about AI. And for all those, what you may hear, right? AI will take your job. If AI takes one type of job, AI creates 75 different types of jobs. There was never a job of a data labeler. There was never a job of a machine ML ops engineer. There was never a job of cloud admin. There are 50 jobs created, and they are high-paying jobs. So, humanity has always found a way. And remember, at the end of the day, these machines are not conscious. It does not know, even though it is driving a car, it does not know it is driving a car. Even though it's playing chess, it does not know it's playing chess. Even though it says this is hot and this is cold, it does not know what is hot and cold. It only knows a vector, a number, and that's all it is doing. So these are unconscious systems that needs a human to tell it what to do, a human to train it. In future, they may auto-train themselves. They may fetch the data automatically on a timeline, and they may auto-train themselves. All that is possible, but again, it needs a stitching of data, cloud, AI models, and then many other product designers, user experience designers, front-end coders, API coders, database architects, cloud architects, AI strategists. It's an orchestra, literally. Next slide. Now, I'm not, again, so the slide on the left was a slide by McKinsey. And that's on the left-hand side, if you look at it, is the likelihood of usage. On the x-axis is the types of problems that it can solve, the types of algorithms. And this is a slightly old diagram, maybe sometime around 2018 or 19, probably. The picture says that all the big ellipse on the bottom left, the gray shade ellipse, All those techniques was actually created in 1950s and 60s. The gradient descent and all these are 58, 54, 55, nearly 40 years, 50 years old, right? But the neural network part, which you see on the top, the deep learning neural network, this was only with some research labs till about 2015 December, when Google open sourced TensorFlow. Before that, some deep learning models, some experimental coding models were available to some researchers in some research powerhouses, right? And machine learning, we studied in college. We studied regression, logistic regression, and somebody who's done operation research would have studied transportation models, assignment models, dynamic programming, linear integer programming, simplex methods, linear programming techniques. All that we've studied, and these are all techniques from the 50s and 60s and 70s, when matrices and vector algebra, matrices and the use of computer for solving matrices happened, right? What we used to solve in college, we used to have a question on Kramer's rule, and then we would make those that determinant and then find. Now imagine when I was in aerospace, we used to have millions of such equations for solving the computational fluid dynamics equations, or the differential equations for combustion, and the stoichiometric combustion ratio for air-fuel mixture. Now, all these were possible. Everything gets converted into some linear equations, and now you have millions of linear equations, and you solve using computer rather than a hand calculation. Right? So the McKinsey's picture is telling you that as we go into the future, and the future is now, more and more products and services which you use just like that will have deep learning in it. Your Alexa, your Siri, they all use deep learning. The the Facebook picture tagging goes through large deep learning networks, convolutional neural, 2 large CNNs. I mean, they may change. I cannot say with authority, but whatever I had read. So as we keep going into the future, the education platforms, the learning platforms, marketing platforms, they will all be using more and more deep learning, because it is based on pattern, and deep learning becomes better and better as the data sizes, number of features increase. Statistical models suffer from a problem called collinearity, coupling. So if you have an equation, y is equal to a1 x plus b2 y plus c3 something, and if this x1 and y and c all these are connected, then your accuracy of the model will suffer. If there is an interaction between the right-hand side variables, then the accuracy of the whole model is called the problem of collinearity. And some of you who are studying statistics and math would somehow know about it, and some MBA students would also know about it. So the impact of statistical models decreases when on the right-hand side, there are a large number of coefficients and the large number of variables, because of the problem of collinearity and dimensionality, and hence the accuracy. Of course, there are techniques to improve the accuracy even when you have this is the problem. But again, more and more neural networks get better with more features and more data. They don't get worse, unlike statistical models. Now, on the right-hand side, I just shown you a statistical model, and on the extreme right is a neural network. They are different ways of solving the same problem, right? So a neural network will form, is a pattern matching, basically. It's called representational learning, where a cat and a dog is a vector, and the distance between the two will decide how different they are, right? And in neural networks, even if you don't know the domain, you're not an expert, you don't know what is impacting what, you can put all the features, as many features, into the neural network and train it. In the statistical model, you need to be some kind of a domain expert to say that x1, x2, x3, kaise select karna hai? How do you select x1, x2, x3? So there you need some domain expert, some understanding. And don't get me wrong, it doesn't mean that neural networks you don't need domain expert. But the machine can slowly become the domain expert, and you can do much better in many areas, especially when the data set is large and the number of features are large. Next slide. Now, again, I'm not going to teach you deep learning today, but it doesn't matter whether it's machine learning, statistical models, or deep learning. You'll always follow the steps. You'll always collect data. You'll clean the data. You'll prepare the data. Now, you'll select what part of, like age, gender, height, weight, address. All these are features. And not every feature is important for the problem. So you will decide, okay, I have so much of data, but which part of the data is a feature? And whatever is being used in the equation is called a feature. So you'll do some collect the data, clean the data, normalize the data. You'll do some feature engineering, some sandbox trials. You build a couple of models. You'll never build one model. You may build a logistic regression model, or you may build a CNN, a convolutional neural network. You may try some other models. You may build a random forest model in statistical modeling, and you'll try to see which model is getting you better accuracy. Then you'll train the model, of course, and you'll test the model. And on the right hand side, there are different types of business problem. You want to classify your quality kharab hai ya acha hai. So it's a classification problem. You can use a statistical method called logistic regression, or you can use a convolutional neural network if you're using deep learning to solve the same problem. Ki ye part kharab hai, ye part acha hai, using supervised learning. And then there are prediction problems. Well, how do you predict that this part after 20 days is going to fail because of such behavior or such features, right? And again, you can use logistic regression, or you can use convolutional neural network or other techniques. And classification, अच्छा है बुरा है, high points, low points. आपके जो likes देते हो, thumbs up देते हो, thumbs down देते हो, they are all classification problems. And then of course the optimization problems, right? Actually the classification यहाँ पे शायद 2 बार आ गया गलती से. One of the classifications can be natural language processing. You want to understand natural language. English समझनी है, French समझनी है. The machine will read. जैसे translation में natural language processing they use today. Now all these things may need mathematical techniques. You may need linear algebra. You may need statistics, Python programming. You understand multivariate calculus. But that it is not about coding. You need someone to understand the business problem. There are other supporting skills that are needed. Please don't think that in a digital economy, the only job is of a coder when you finish mechanical engineering or a computer engineering or whatever. There are so many different areas, and people who are solving these models, the modelers are working as a part of a team. They need to talk to the front-end engineer so that when the model output is given, how do you render it on the front end using Angular or React as a front-end framework? And then how do you design the API? Where will this data come from? How will the model ingest the data? How will the model be trained? And firstly, which model? And then what is the business problem? So all this, the mathematics side of the AI modeling is one part, but there is a whole science and art on the other side of defining the business problem. Where is the data? Is AI the right solution? How will cloud change the dialogue? How can we build competitive advantage and go to market faster, better, cheaper than the customer? So it is important to be mathematically good when you're doing AI, but AI is also not only about coding in TensorFlow or writing using scikit-learn to build a statistical model. Next slide. The top 3 challenges in any company today, and this is my 16 years of experience in the US, and I'm sure it's no different in India. That सबसे बड़ा problem है, company बोलती है भैया AI, cloud और data तो ठीक है, पर कौन सा problem solve करें इससे? Which problem do we pick up first? And this is a classic case of every company which is not digitally savvy. You can't say that, oh, CIO के अंडर में 5 लड़के हमने hire कर लिए and from Mansour University और अभी हम लोग technology advance हो गए. ऐसा नहीं होता. So you need to have people who understand how to identify the right use case for AI, cloud, and data enablement, how to get access to labeled data, understand what are the ways of getting the weather data, user behavior data. And then remember, most important, the talent has to be in every department, not under the CTO or the CIO or the CEO, or it has to be distributed. Otherwise, organizations can never thrive. So it is not just about technology skills in AI, cloud, and data. It's also about understanding the business rationale, the marketing domain, the sales domain, the product management, the voice of the customer. There are hundreds of these jobs in a digital enterprise. Coding is not the only job. Next slide. I just put this because I'm talking to an institution. I'm not going to run through this. I'm sure you can share this, but you know, different levels. There are AI ML engineers who could be fresher. You need some coding skills for sure. You need good basics of math and statistics. And you need to, if you know Python programming, it's very useful. You need to have a good engineering degree. In the US, even English majors do coding. I don't understand, but I think it is possible because I've seen them code. And but again, every country has its culture, so we should accept and embrace that culture. But with the fundamental coding skills and baseline math and some deep learning courses, you with a good decent engineering degree, you'll be able to get good, decent jobs as AI ML engineers in any digital organization. Between 5 to 8 years, you'll start leading an AI team. Between 8 to 10 years or 12 years, if you have a management degree, and you may or may not have an engineering degree, but you have some good certifications, you can actually become a program manager where you lead a team to decide which features we should build, like the Google engineers, the LinkedIn engineers, the Facebook engineers. Program manager and the business analyst, technical program manager is a very, very product managers. These are very, very crucial roles. Today, all of us are hooked onto the phone because they're designed that way. The entire user experience design is like that. You should see the movie on Netflix, Social Network. It's a very serious movie to say how our behavior has changed. Our attention spans have changed. We have attention less than a goldfish, less than 6 seconds today as humans. My wife, she never bought anything online. Today, she hardly goes to a store. Our buying behaviors have changed. The digitization, the way the products are designed, the user experience has changed our fundamental decision-making process. This is serious. So these are all the roles, or developers, and then of course. So I just wanted to put this slide so in case it is shared, you will have access to it. Next slide. These are some of the links, again, for some of the people who want to learn AI, ML, Python, and cloud. So these are the links I have used myself, and I have put there. I've tested some of those links, so you can definitely use them. And then there are other areas. The Harvard iLab lectures are very good for people who are interested in doing startups and building platforms and products. So you should listen to them. They're all free, available on YouTube. And I've used them about 5, 6 years ago, 8 years ago. But they are very, very solid lectures by private equity company holders and venture capitalists and funding agencies and so on and so forth. Next slide. So as I said, it's just not about coding. Please don't misunderstand. The digital place for you to manage and lead, you first find your aptitude. And it's not all lost if you don't like coding. There is system analysts, there is business analysts. There are other things that you can learn by certification, by being part of some self-help groups. You can be part of the online forums. You can attend free lectures like this, many webinars, and you can build a portfolio of your capabilities. On the overall understanding, these are some good books. Competing in the Age of AI is written by Professor Karim Lakhani. In 2005, when I landed at MIT, he was my teaching assistant. He was doing his PhD in marketing at that time. And a very fine gentleman. And he's actually a Pakistani from Canada, but very smart and very gifted. And later he became a professor at Harvard after his PhD. A very good book, Digital Disruption. So these are some of the good books that you can read. The top books are generally management thinking, business thinking, problem formulation books. And some of the bottom books like deep learning again, and the statistical analysis. I've used that a lot when I gave some training lectures on Python programming, on TensorFlow programming, and on mathematical modeling. I've used these books, some of these books, and I've of course read, but I just wanted to put it here so that it is of value to you. Next slide. You can use these books in your book club. Most important part, this is my last slide, and as I said, I try to stay away from anything that you can Google, and I try to give you my own experience. It is not difficult to succeed in a digital world today. If you understand the foundational stuff, you need to be good at your craft. I remember I was in a meeting at Apple about 4 years ago, And the gentleman there, the Apple architect, said, Rajiv, I don't care if the developer is Chinese or Indian, or if he's not very good in English. I don't need English. I need a good, well-written code, right? And people value you to what you bring to the table. So the first doubt when you get in your mind, am I good enough for a global market? Remember, there is a place for you. As long as you're good in your craft. If you're a batsman, as long as your bat does the talking, nobody cares whether you can what you do after the game, right? And it's not about technology. It's about ability to convey your thoughts in a simple way. It doesn't have to be a very flowery, bombastic language. Steve Jobs never did that. Bill Gates never did that. Or Narayan Murthy never did that. Right? So you don't have to, you understand, as long as you can convey your hypothesis in simple words, that is the most important thing. Today in my company as a CTO, my first mantra is, please convey everything in one page. What engineering principle you're trying to show. That helps, right? There's a saying, if only I had more time, I would have written a shorter letter. So writing concisely, simply is a very good skill. Continuous learning. Even today, I read every day, I learn every day, and there is nothing that I get surprised after so many years in technology. So yeah, continuous learning. And remember, 5 data scientists cannot make an intelligent platform. It's an orchestra. You need a front-end engineer, a full-stack designer, a UX designer, a database modeler, data architect, cloud architect, AI strategist, product manager, agile scrum master, mathematical modeling, DevOps engineer. It's a cross-functional game. 5 data scientists cannot make an AI platform, right? And lastly, every organization is struggling for talent and passion, and you can't teach this, right? This has to come from inside. Yes, the teachers can kindle this in you. Brigadier Rawat sir and I, we are from the army, and for us, we fashioned on our instructors' days to motivate us. So similarly, as teachers, as professors, you could be the motivating beacon of light for the students when they watch you, how you teach, how you speak, how you conduct, what books you read. Yes, possible. But again, passion and talent cannot be taught. Skill can be taught. So with this, I'm open to questions.
Now it's time for question answer round. If anyone asks some questions to sir, please come near the podium.
I think there were a lot of questions.
Sir, thank you to have invited us with a great knowledge. I have one question. We are also having the business intelligence to make the decisions in the business, and also we are having the area map. So I want to know that which one is better to go for that, making the decisions or optimize utilization of the resources in the business.
So I think I didn't hear you very clearly, but you talked about business intelligence. And the second part of the question, I heard the BI part. What, can you just repeat your question?
Sir, my question is that we are also having BI, business intelligence, as well as we are also having the AIML, that is the machine learning. Okay. So which one is better?
Okay. See, business intelligence is descriptive. It tells you what is now in the data. For example, I may collect data from different shop floors. I will make a plot, right? Now, and I will get some insights that this is how these 2 items are changing. My inventory is going down or whatever, right? Now, BI is always about uncovering the patterns in the as-is state of the data. It is not predictive. It is not prescriptive also. Now, if you want to build a recommended model, कि ठीक है, ये हो रहा है तो हो रहा है, अब मैं क्या करूं, right? So now, if you want let's say, for example, I will come to you, you're an expert, and you say, Rajiv, I see this, you better do this, right? Now, you as a human expert are able to look at the data and then tell me, recommend me something, right? And also, you may say, मेरे को लगता है 3 साल में ये तो चलेगा नहीं और, right? So that is where you need predictive capability and prescriptive capability. That cannot be done through BI. Predictive capability and prescriptive capabilities can be done through machine learning. And I remember a McKinsey report that if you use predictive and prescriptive algorithms, you will increase the business insights and revenues by more than 30 to 40% as compared to using only BI.
Thank you, sir. Thank you.
You're welcome. I hope I've answered your question.
Yes, sir.
Good morning, everyone. Good morning, sir.
Hi.
For the
Good evening.
25 years of leadership with a background in AI, enterprise architecture, process design, right? And as well as the energy to help propel the grid dynamics in its new stage of progress, right? So prior to joining grid dynamics as officer, you served as the senior vice president of cognitive digital Pactera and as the Chief Solution Officer of Ness Digital Engineering. In Grid Dynamics, the partners were AWS, Amazon Web Service, Google Cloud, Microsoft Dataiku, Harness, Lenses, whereas in the Pactera Edge, the partners were Microsoft Azure, Power BI, MongoDB, UiPath, 9, Azure Cloud, and so many more. And in the lastly, in the Ness Digital, the partners were AWS again, Microsoft Azure, Confluent, Salesforce, Snowflake. So my question is, in which organization you felt working is the most challenging and exciting in terms of the understanding the business needs of the partner and providing them satisfactory business solutions? Thank you, sir.
No, sure. It's a good question. So let me be very honest. Like Brigadier Rawat would agree, right? All the plans go out of the window when the first bullet is fired in combat, right? Because the enemy always comes from the fifth direction. In corporate life, all the plans, the moment you face a customer, a client, the client suddenly brings a very different perspective. कि मुझे तो ये चाहिए था, आपने ये बना दिया, right? Now, so the first thing is, if you look at my career, I had a chance to be in code development. I had a chance to be in solutions and enterprise architecture. I had a chance to be in customer relationship management very early on in Polaris. And now I'm the CTO. But I had the luxury and the privilege of working in all the different types of roles in technology. And there is no one side which is easier than the other. Solutioning a problem with very less information is a challenge. Delivering a platform with a team of 10, 12, 15 engineers on time, on budget, on schedule is a challenge. Things go wrong. Plans go wrong. You thought this job will take 20 hours. It took 96 hours. And so, there is no such thing as ye to aasan hai aur ye mushkil hai. But I can tell you that facing a customer and being able to convince a customer is the most hardest part, which needs you to think on your feet, be very simple and clear, and bring solutions based on your experience. So customer facing roles have its own unique challenge and fun also. Could you hear me? Did you lose me?
Hello, sir. Repeat the answer once again. There was an issue.
Yeah. Okay. So I said it's a good question, and I said that I've had the chance, a privilege to work in different roles in engineering, delivering the platforms, in designing solutions before you deliver, and in relationship management with the customer, and then in building a deep learning company, No IQ, from the scratch, working with venture capitalists and private equity firms. There are challenges in all these roles. None of these roles are straightforward and simple. They are not sequential. But the most important challenge is when you face the customer and when you're trying to understand in a workshop the customer's actual problems, whiteboarding them, converting them into an engineering implementation plan, and then executing them. Each one has its own challenge. I personally like facing the customers. I like doing the solutioning, and I still do enjoy coding, though my role and I don't have enough time but I definitely, guide and mentor my engineers. Yeah.
Thank you, sir, for providing.
Yeah. Hi, everyone. I'm back. Yeah. So there was some problem.
Okay, next question. Good morning, sir. Good morning, everyone.
Hi, morning.
Yes, myself, Jatin Gabler, student from CSE branch. So my question is, please share your journey as an entrepreneur of two successful startups.
Yeah. You see, the journey of an entrepreneur, you think I'm successful and it's like this, but it is actually like this, but I'm still going up, right? So imagine a graph which is going up and down, but upward slope, right? So an entrepreneur's journey is like that. It is never a straight line going up, right? There are a lot of times when you don't have funds. There are times when you don't have engineers, you don't have money to hire engineers. So you do number of jobs together. You need to build a report and get in front of the customer very quickly. The resources are limited. I think being an entrepreneur allows you to be innovative. It allows you to solve problems with simple approaches, and it allows you to face challenges head on, right? So in my journey, I've worked on two startups. Not first one was definitely not successful, but it taught me how to be a CEO in my head. The second one, no IQ, was a good one, and which was again merged with Pactera Edge. But my learning is that as an entrepreneur, you never get worried about failures. You accept them, you learn from them, just like a boxer. You take the punches, you hit, you stand up again, you brush your gloves, and you start again. So yeah.
First of all, I would like to tell that we have pasted the feedback link in the chat section. All the participants who are watching this program may give their feedback. And thank you so much, sir, for sharing your experience, especially on digital learning platform, integration on social economy, idea of taking advantage of internet, AI-powered business process with artificial intelligence and machine learning models, and many more. We really feel glad to have opportunity to listen your experience and also feel grateful to have such personality with us. So last but not least, I would like to call Dean Faculty of Engineering, Dr. Pradeep Lakshkar sir, to propose word of thanks.
Thank you. Good morning, all of you. So, as we have come to the closing of the session, it is my privilege to deliver the vote of thanks. So, first of all, I would like to propose a hearty vote of thanks to our guest, Mr. Rajeev Sharma, for gracing today's webinar and delivering knowledgeful session on managing and leading in a digital world powered by AI, data, and cloud. I would like to thank Honorable Vice Chancellor, Mysore University, Brigadier Dr. Bharat Singh Rawat, Dean Academics, Dr. Shailen Sharma, Registrar Ashish Parikh, and Dean Administration, Colonel Anand Kumar, for their support. I would like to thank all the faculty coordinators for making this event a successful event. I would like to thank the management of Mysore University for supporting us to organize such events. And last but not least, I would like to thank all the participants. Without you, all this event would not have been possible. Thank you, one and all. Thank you.
Thank you very much. Thank you, sir, for this opportunity. Thank you.